This video shows some of the functions of the visual Servoing GUI and how to use them. First of all, you need to select the video device. For instance, here I have a UHD Pro camera connected in a format YUYV422. On video 1, there's nothing connected, and then we also have the internal camera of the Raspberry Pi, which has a lot of formats possibilities. For this demo, I'm going to use the UHD camera on video 0, and this is in the UF422 format, and select the size of the image. I'm going to select not the biggest one, but something in between. Then we can start the image processing by pressing the image processing button, and here is the window, the viewer for the VSGUI. We grab the image continuously at a frame rate of 15 frames per second. There are a lot of methods you can choose from. One is the edge detection method, which is computationally heavy. For the Raspberry Pi, you see the frames per second dropping to 7 or 8. We can improve this by using multiple threads. All the image processing methods are programmed that you can use them in multiple threads. And you see that we are using now 2 threads, dividing the processing load over 2 cores, and the frame rate goes back up to 15 frames a second. The fourth method shown here is a gravity of white. White pixels in the image are turned blue, and then the center of gravity is calculated. With this method, you can also use PID control to control motors connected to the output. For instance, by using the PWM outputs 1, 2, or the soft PWM. You can see that when we move the object in the image, the center of gravity changes and is calculated and shown in the interface. At the end, the object is always in the center of the image. Let's stop the control loop and go back to simple image processing. The image viewer will close and opens again. There are some methods left, for instance, red, green, blue detection. The image speaks for itself. Then it's also possible to perform mask operations on the image. Here we detect horizontal lines, but you can change the parameters. For instance, when you want to show the original image a little bit more, you need to increase the weight of the center pixel. You can also choose to detect lines in other directions. Feel free to test this module. The calculations are performed on the Y component of the image. Then we have the movement method. Differences in consecutive images are detected, and the last method is a tracking method. I will explain this one in a next video. Going back to the main window, there are still some parameters which you can set or change. For instance, like the sample time, which determines the frames per second you can reach, but that's for another video. Thank you for listening. I hope you learned something from it.